So in this data sufficiency problem, we're given that there are n students, and these students need to be assigned to m classrooms. So we're really just dividing this many number of students into m classrooms. And we're given further constraints on m and n. M is a number between 3 and 13, and it's an integer. So any of the numbers 4, 5, 6, 7, all the way to 12. And n is a number that's greater than 13. The question is it possible to assign each of these n students equally amongst m classrooms? So this is actually a number property problem where they're essentially asking, is n divided by m an integer? For example, here, if n was 24 and m was 4, yes, I can assign 24 students equally amongst 4 classes. Each class would have 6. So that would answer this particular question as yes. And we need to determine whether there's a definite yes or definite no. So if you look at statement 1, it says, it is possible to assign each of 3n students to m classrooms, which means 3n student can be equally divided amongst m classes, which means 3n over m is an integer. So this is really a divisibility problem. So the question is, if 3 times n over m is an integer, is n over m an integer? And I'll illustrate this with some examples here. For example, if m is 5, I'm picking m as 5, and if I picked n as a multiple of 5, for example, n could be 15. In this case, certainly this would be an integer because this would be 3 times 15 over 5, which is 9. So I do satisfy statement 1. In this case, the answer to the question is n over m an integer. 15 over 5, is that an integer? And we would say yes. So now the question is it possible for the answer to that question to be no? So if we look at this piece, I want to force n over m to be not an integer, because that's what would answer the question as a no. So I know that if I somehow include a multiple of m to be a multiple of 3, so let's say it's 3 times something. For example, I could do 3 times 2. And here, so this 3 and this 3 would disappear. And I still need to force this to be an integer. And so if I pick, say, a number like 16 here, so this 3 goes out, I do satisfy my statement. So my values of m and n are n is 16 and m is 6. In this case, 3n over m is an integer because 3n would mean 48 students can be equally divided amongst 6 classrooms. Each class would have 8. But now if I were to answer the original question, could these n students be divided equally amongst 6 classrooms? And we'll say 16 over 6 is not an integer. So that answers the question as a no. So statement 1 is insufficient, meaning this isn't enough to conclude whether n over m is an integer. If we look at statement 2, it says, it is possible to assign each of 13n students to one of the m classrooms. So what they're saying is 13n over m is an integer. And the question is n over m an integer? So I'm going to rewrite the constraints on m and n. So m is a number between 3 and 13, and n is larger than 13. So we need this result to be an integer, and it becomes 13 times n over m. So if I look at the possible values of m, it's between 3 and 13, meaning 4, 5, 6, all the way to 11 and 12. None of these numbers are going to divide 13. 13 is a prime number, and none of these numbers from 4 to 12, or numbers less than 13, would be a factor of 13, or would have a common factor with 13. Which means that for this result to be an integer, m must divide n. So, which means that n over m must be an integer. That's the only way I can satisfy statement 2. And which is really what the question is. Would the number of students be equally divided into a classroom? And the answer is a definite yes. So statement 2 alone is sufficient. And the correct answer is B.